Was affected by the magnet issue from China because the Optimus actuators in the arm do use permanent magnets. Now, Tesla as a whole does not need to use permanent magnets, but when something is volume constrained, like an arm of the robot, then you want to try to make the motors as small as possible.
22 degrees of freedom, a price under $20,000, and a goal of pumping out millions of units before 2030. Numbers so wild they've got Wall Street holding its breath as Elon Musk gears up to hit back in the latest tariff war. What looked at first like a simple gripe about duties turned out to be the moment Tesla secretly tuned Optimus Gen 3. A leaner controller, a timeline slashed to 1/3, and the sticker price pushed below $20,000. But can Musk really ship millions of robots before 2030? Or will export permits clamp down on Optimus's 22 degree of freedom hand? The answer awaits in today's episode of Tesla Car World. So, how do Tesla Bot Gen 3's price dynamics change? Can a $20,000 humanoid survive a magnet squeeze? That single question now hangs over Optimus Gen 3, the third-generation Tesla bot that once promised to undercut every industrial cabot on the planet. Tesla's Optimus Gen 3 humanoid robot isn't the reckless gamble some imagine. From day one, the project has smartly tapped the world's most seasoned EV supply chain, paired it with an AI platform running in more than 5 million cars, and thrived in a culture that tackles problems in full view of the public. New rare earth export rules have certainly pushed up component costs, especially for magnets, but Tesla once turned a battery bottleneck into the edge that put the Model Y on top of the market, and now it's applying the same playbook to magnets. Elon Musk's promise of about 20 grand once we hit serious volume still stands, because he was talking about a falling price curve, not a single fixed number.
You also need to be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
Industrial robots have taken the same journey. Back in the 1990s, ABB's first 6-axis arms cost as much as a supercar, but today you can lease one for less than a forklift. Optimus is on that same path, just moving faster thanks to Tesla's habit of iterating in public. Internal slide decks, leaked to analysts in March, position $40,000. That figure is only a temporary scaffold. It covers pilot-run tooling, certification paperwork, and leaves a bit of profit to fund the next round of cost reductions. Once Gigafactory Texas turns out its 10,000th actuator, fixed costs will drop off a cliff, and every learning cycle will shave more dollars off the bill. In short, $40,000 is just a placeholder, not the project's ceiling. But the so-called magnet crisis, Tesla already has 3 solid backup plans. First, right after Beijing announced its new export rules in April, Tesla's lawyers filed several applications for civil-use export licenses in China. The same play they used to keep Model 3 production rolling during the 2019 tariff showdown. Reuters says the company expects approvals in weeks, not months, so that the supply line should stay open. Second, new magnet factories are popping up at home. In January, MP Materials began producing commercial NdFeB alloy in Texas and pledged nearly $1 billion to rebuild a complete mine-to-magnet pipeline in the United States. The planned capacity will easily cover both electric vehicle demand and the magnet's Optimus needs. Third, Tesla's engineers are already testing motors that use up to 30% less neodymium. By tweaking drive modes and improving how the metal grains line up, they can cut long-term costs, even if Chinese exports stay tight, and they'll reap extra savings once US-made magnets arrive. In short, magnets may slow things down a little, but they won't stop the project. Any of these 3 options can absorb delays without knocking the 2025 pilot builds off course. Musk, speaking at the last shareholder Q&A, didn't sugarcoat it.
Was affected by the magnet issue from China because the Optimus actuators in the arm do use permanent magnets. Now, Tesla as a whole does not need to use permanent magnets, but when something is volume constrained, like an arm of the robot, then you want to try to make the motors as small as possible. So we did design in permanent component magnets for those motors, and those were affected by the supply chain, by basically China requiring an export license to send out any rare earth magnets.
Translation: the bill of materials that once penciled in under $20,000 now creeps north of $25,000 before a single unit leaves the factory gate. BCs, Elon Musk admitted in the same session.
Almost everything in Optimus is new. There's not like an existing supply chain for the motors, gearboxes, electronics, actuators, really anything in the almost anything in the Optimus, apart from the AI for Tesla, the Tesla AI computer, which is the same as the one in the car.
Inside Tesla's robotics group. The new mantra is, price is a slope, not a point. Internal slide decks leaked to analysts in March position $40,000 as the introductory commercial batch tag. Double the founding myth, but still disruptive when you benchmark against ABB's GoFaw or Boston Dynamics Atlas-based service bundles. Why the premium? Start with raw inflation in magnets and aluminum, add bespoke calibration rigs, factory acceptance testing, and a multi-layer safety software stack that automotive plants never had to field. Layer on regulatory certification for collaborative workspaces and you arrive at a cost stack far thicker than the one behind a crossover EV. Tesla's finance team is also baking in a software-as-a-service layer, over-the-air skill packs, machine learning reflex upgrades, and predictive maintenance dashboards. Early language points to a maintenance and intelligence bundle in the $200 to $400 per month range, eerily similar to how Fanuc and Yaskawa sell cloud analytics for their 6-axis robots today. For warehouse managers unwilling to swallow CapEx, Tesla is floating a leasing tier at $300 to $600 a month once production stabilizes. Crunch the numbers. Across an engineered life of 10 years that equates to $36,000 to $72,000 net present labor cost. Still cheaper than hiring a single U.S. worker at median wages for 12 months. Better yet, the contract lets lessees roll into Generation 4 hardware without carrying depreciation. In other words, Tesla wants to turn its humanoid into an operational expenditure line item, not a balance sheet anchor. Critics frame the rare earth squeeze as Optimus's kryptonite. Yet history suggests Tesla metabolizes crises into speed. Remember the nickel crunch of 2022 or the infamous 4680 cell ramp? Musk's playbook, parallel sourcing, long horizon contracts, vertical integration, kept Model Y volumes climbing while rivals idled. The same tactic is now in motion for magnets, simultaneous license filings in China, deeper ties with MP Materials in Nevada, and Linus in Western Australia, plus exploratory investments in European sintered magnet lines. In parallel, R&D teams in Palo Alto are testing stator topologies that cut neodymium use by up to 30%, while control engineers prototype field-weakened drive modes that wring more torque out of every gram. If successful, those tweaks will echo through future cost curves long after export rules relax. Tesla's target buyers, think FedEx hubs, Carrefour distribution centers, and Target backrooms, care less about calendar hype than uptime. Even a slip from later the third quarter into the fourth quarter dovetails with warehouse retooling windows ahead of the 2026 peak season crush. Every extra month of internal fleet testing at Fremont or Austin raises confidence in durability, sharpening the sales pitch. Meanwhile, policymakers on both sides of the Pacific now see Optimus as strategic infrastructure. China pockets license fees and showcases that its minerals can power non-military AI. The U.S. gains a flagship manufacturing story to counter gloomy robots killing jobs headlines. That geopolitical spotlight all but guarantees expedited paperwork and perhaps even loan guarantees for Western magnet startups desperate for anchor customers. So, where does all that leave the spreadsheet? Pretend you're a logistics VP staring at the $40,000 purchase price plus $300 per month intelligence subscription. Amortize the asset over 10 years at a conservative uptime of 6,000 hours per year. The effective labor cost lands under $1.20 per human equivalent hour, a fraction of the $15 to $25 many U.S. warehouses now pay after insurance and tax. Slice another 10% for energy because Optimus sips under 1 kilowatt-hour per hour, far below a forklift, and the margin stack remains appetizing even if magnets stay pricey for years. Moreover, software unlocks incremental revenue. Need your robots to learn a new pallet pattern? Buy a $99 skill pack and roll it OTA to every unit overnight. Exactly the annuity model Wall Street rewards. Tesla isn't selling cheap hardware. It's laying rails for a perpetual license economy very few incumbent robotics firms have mastered. How Optimus' hand leaps beyond human-like dexterity. The signature upgrade in Generation 3 is the hand assembly, 22 degrees of freedom with every motor gearbox pair moved from the palm into the forearm, linked by tendon-like cables. That relocation is more than cosmetic. It lightens the distal mass so the wrist can accelerate faster and the fingertips can manage delicate grasps without the flywheel effect of heavy motors. It does, however, double the mechanical complexity relative to Gen 2, because each degree of freedom now needs a low-friction cable path, capstan, tension sensor, and a periodic retensioning routine. Historically, builders such as NASA's Valkyrie and Aptronic's Apollo report that cable tendon systems demand millimeter-level alignment and show a higher maintenance burden than direct drive wrists. Tesla is betting that its mass manufacturing discipline will push those tolerances into repeatable automotive-grade fixtures. Power comes from a single 4680 lithium-ion pack, essentially the same cylindrical format that underpins the Model Y, yielding a claimed 10 hours of mixed task endurance. That figure implies a usable capacity near 2.3 kilowatt-hour and draws of 200 to 250 watt while walking, consistent with published data on similarly sized bipeds. If true, it suggests Tesla's thermal management is good enough to avoid active liquid cooling, which would otherwise add mass and service complexity. The admission cuts both ways. It justifies delays caused by rare earth magnet licensing, but it also flags a fundamental risk. Quantities built at automotive scale must survive millions of cycles, and no public endurance testing data exist. Until Tesla discloses load curves or invites third-party labs to verify them, buyers cannot gauge whether Gen 3 is a warehouse workhorse or merely a sophisticated demo rig. On the computer side, Tesla is doubling down on vertical integration, the same FSD inference. Computer and dojo-trained vision stack that pilots its cars also animate the robot. From an engineering lens that is elegant, sensor fusion, occupancy grids, and motion planning are transferable abstractions across wheels and legs. It also means the safety kernel, over-the-air update pipeline, and fleet learning telemetry have a decade of field hardening behind them. The immediate consequence is that Optimus can inherit a petabyte-scale, curated video corpus and an auto-regressive policy network without reinventing perception. For Tesla, the rationale is twofold. First, legal. A curated runtime limits user modifications that might compromise functional safety or violate export regulations. Second, economic. OTA feature unlocks can be sold just as Tesla sells acceleration boost or full self-driving packages for its cars. During the rare earth supply discussion, Musk framed,
Everything we've developed for our cars, the batteries, power electronics, the advanced motors, gearboxes, the software, the AI inference computer, it all actually applies to a humanoid robot.
We will get a license to use the rare earth magnets. China wants some assurances that these are not used for military purposes, which obviously they're not. They're just going into a humanoid robot. So it's not a weapon system.
Optimus is a platform whose capabilities will expand over time. Internal slides leaked to employees spell out an App Store-like revenue model where advanced manipulation, culinary, or language modules are microtransactions. Gen 3's physical innovations, lighter fingertips, tendon cables, and long-range 4680 power, could, on paper, push humanoid utility past the threshold of economic viability. Yet technical opacity around payload and durability, compounded by an intentionally closed software ecosystem, leaves would-be integrators in a holding pattern. If Tesla can ship the missing specs, certify a supply chain unchoked by rare earth geopolitics, and convince developers that a paywalled skill store still allows real customization, Optimus may justify its hype. Otherwise, the platform risks repeating a familiar robotics story, stunning demos that stall at the gate of practical deployment. How does Tesla produce Optimus without tariffs? Tesla's response to escalating tariffs on electronic components and rare earth materials has been to push decisively toward vertical integration, and by the first quarter of 2025, that strategy was already reshaping the Optimus Gen 3 program. 72% of the robot's parts now come from suppliers in North America, a steep rise from 45% just a year earlier. Rapid expansion of new manufacturing lines in Texas and northern Mexico has brought electric motor, gearbox, and battery pack production in-house, trimming the average cost per robot by 18% and enabling the company to hit its ambitious 9,950 retail target while tightening control over its supply chain. Elon Musk framed the build-out as an essential hedge against geopolitical risk, noting that Tesla invested $2.4 billion in Optimus-related infrastructure during the quarter and expects to earn that out within 3 years on the strength of rising global demand for service robots. The company is already gathering operational data. More than 500 Gen 3 units work inside Tesla's own gigafactories, handling material transport, inventory tasks, and routine machine maintenance in ways that have lowered factory operating costs by 17%. Beyond the factory floor, the robot's societal footprint is taking shape. In California, hospitals' Optimus is being piloted as a mobility assistant, where early results show a 23% improvement in patient support services, and a broader healthcare rollout is scheduled for 2027. Domestic trials are similarly encouraging. 200 households in a closed beta report a 94% satisfaction rate with the robot's autonomous cleaning, basic food preparation, and personal assistance features. Even SpaceX plans to deploy Optimus during future Mars missions, using the machine for construction and maintenance in environments too hazardous for human crews. Is the plan to sell Optimus for under $10,000 a real breakthrough, or just marketing hype while rare earth magnet costs keep rising? And Tesla says it will ship millions of robots before 2030, but if China's magnet export licenses stay tight, will that roadmap turn into a pipe dream? Please share your opinion in the comments section below this video.
You also need to be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000.
Elon Musk has made at least 4 prior statements asserting that the Tesla Bot Gen 3 is confidently projected to retail for $20,000, and potentially as low as $10,000 once scaled and maintained under 400 watt-hour per hour. At that rate, the cost would be around $0.05 per minute for household tasks, cheaper than the minimum wage in 49 states. And Musk's latest move genuinely shocked us all. Instead of choosing between politics, Doge, and EVs, Tesla is going all in on a product that could expand its total addressable market by 10 times without disrupting its existing lineup. For price-sensitive users, privacy-conscious skeptics, and fans of all things cutting-edge, Gen 3 aims to answer the age-old question: will this robot actually make your life easier and pay for itself? During Tesla's first quarter 2025 earnings call, Elon Musk confirmed that the announcement set Twitter ablaze.
And I think starting probably in next month, May, my time allocation to Doge will drop significantly. Starting next month, I'll be allocating far more of my time to Tesla.
Investors were quick to link Musk's pivot to Tesla's disappointing first quarter results. Revenue dropped 9% year over year to $19.34 billion, and earnings per share plunged 71%. The immediate question on everyone's mind: where will Tesla's next engine of growth come from? The truth is clear that Elon Musk laid out a target that few outside the EV bubble seem to notice.
We hopefully will be able to make about 5,000 Optimus robots. We're aiming for enough parts to make 10,000, maybe 12,000, the 10,000 now. But even 5,000 robots, that's the size of a Roman legion, FYI, which is like a little scary thought, like a whole legion of robots.
Such a scale isn't just ambitious, it's essential. It's how you drive unit costs down below the magic $20,000 mark, or even the $10,000 price tag Musk previously promised. So what's so special about Elon Musk's grand overhaul of the Tesla Bot Optimus Gen 3? Picture a regular Tuesday. You've just spilled coffee on the floor, your mom is rushing into a critical Zoom call, and your dog Buddy is anxiously begging for a walk. Instead of panicking, you calmly say, "Hey Optimus, clean the house in the next 30 minutes, then take Buddy for a walk." The robot gives a gentle nod and a soft smile, thanks to its new linear mechanical system that operates at under 40 decibels, as quiet as falling leaves. And just like that, it gets to work, calm, silent, and more efficient than any human could be. That's the future. Tesla's Optimus Gen 3 upgrade in 2025 is aiming for. A future where robots aren't just smart, but graceful, and truly live alongside us. When you take care of your home with your own hands, you'll understand just how valuable this round of hardware upgrades really is. The robot's hand now has 22 degrees of freedom, twice as many as the previous version. What does that mean? It can tie shoelaces, hold a pen, even wash a glass without breaking it. The wrist, which used to rotate in just one direction, can now move in full 3D, making it far more delicate and precise when carrying dishes or handling fragile objects. As we saw in Tesla's own demo, it was nothing short of impressive. The new 22 degree of freedom hand on Optimus Gen 3 isn't just a mechanical limb, it's a precision instrument. It stacked blocks like a kid's toy game, poured water without spilling a single drop, and caught a baseball with pinpoint accuracy. Watching it in real time, we finally understood why Elon Musk devoted nearly half of the engineering effort just to that hand. Payload capacity has also been upgraded, from 35 to 45 pounds, over 20 kilograms. That means it can now carry a heavy laundry basket or even lift a 3-year-old child. But Optimus Gen 3 isn't just stronger, it's more efficient too. Peak power consumption has dropped from 2.1 kilowatt-hour to just 1.6 kilowatt-hour. On a full 2 kilowatt-hour H charge, the robot can operate for up to 6 hours, and it costs less than 30 cents in electricity at current US rates. More power, less cost. Who wouldn't want that, right? If you agree, drop a Y in the comments below this video. Thanks. What's even more remarkable is that Tesla has equipped Optimus with IP56 weather resistance, meaning it can work outdoors, in light rain, or even falling snow. Imagine it mowing the lawn while you're inside, curled up with a book. Pure serenity. All these upgrades aren't just for show. They're about bringing robots closer to real life, not in a lab, but right there in your kitchen, your living room, or your backyard. And that's what truly excites those of us who dream of a more effortless, comfortable way of living. So, how worthwhile is an investment in the Tesla Bot Gen 3? We often joke, if all it does is clean the house and do the laundry, that's already more than enough for a robot. But in hindsight, that's no small feat. In a typical household of 4, daily chores like cleaning, laundry, and yard work easily add up to about 2 hours per day. Over the course of a year, that's roughly 730 hours of labor. With the average hourly wage for domestic help in the U.S. projected at $16.40 in 2025, that adds up to over $12,000 per year. So a $20,000 Optimus robot, if used consistently and effectively, could pay for itself in just about 17 months, nearly spot on with the 18-month ROI forecast analysts have cited. This isn't science fiction anymore. It's a solid, real-world return on investment. Even if you're not ready to buy, you might be able to lease an Optimus Gen 3 for around $1,200 per month, according to a leaked internal memo from Tesla's first quarter meeting. That might sound steep at first, until you compare it. Take, for example, a hotel housekeeper working double shifts. They can earn up to $6,800 a month, including benefits. In other words, even at that premium rental rate, Optimus is still a far more economical option, especially for families juggling childcare, garden work, and elder care, all on a single income. From another perspective, of course, not everyone is thrilled by the idea of a robot roaming around the house. We've heard plenty of skeptics ask, what if it gets hacked? What if someone disables it with an EMP blast? What about my face data, my routines, my home layout? Could that all be exposed? These are perfectly valid concerns, and to be honest, we were worried too at first. But then we read Tesla's response and it gave us some peace of mind. They're not ignoring the risks, they're actively addressing them. When it comes to protection against electromagnetic pulses, the stuff of sci-fi and doomsday scenarios, Tesla has implemented the same robust solutions used in its electric vehicles. Optimus is equipped with a triple-shielded battery system, and more importantly, its entire full self-driving computing unit is encased in a Faraday cage-style architecture, a proven design that shields against electromagnetic interference. And this isn't just marketing talk. It's officially patented under U.S. patent number EUDNO/912443 as of March 20th, 2025. After learning that, we breathed a little easier. This robot isn't just smart, it's built to protect itself from the worst tech disasters you can imagine. When it comes to personal data and privacy, Tesla has clearly taken some hard-earned lessons to heart, especially in light of the legal controversies that unfolded in the U.S., even if they didn't directly involve the company. In response, Tesla has re-engineered how Optimus handles sensitive data. All biometric inputs, like facial recognition, voice commands, and gesture tracking, are now encrypted directly on the device. No raw data leaves the robot unless you explicitly choose to link it with Tesla Cloud. In other words, you're in control. If you don't enable sync, everything stays local. There's no behind-the-scenes data dump to some unknown server. And to us, those who embrace technology but still value our privacy, that's a game-changing promise. There's one thing those of us living in the suburbs, the countryside, or just places with uncooperative weather, care a lot about. Is this robot tough enough? Can it actually handle outdoor work in rain, mud, and unpredictable conditions? And the good news is, Optimus Gen 3 is no fragile machine. According to a spec sheet briefly shown at Tesla's factory preview, this robot is built with an IP56 seal, meaning it's highly resistant to both water and dust. On top of that, it operates smoothly in temperatures ranging from -10 degrees Celsius to 45 degrees Celsius, from freezing winter mornings to sweltering summer afternoons. We immediately pictured it working in dusty barn aisles on a farm or clearing snow off the porch for Grandma and Grandpa. And according to internal sources, Tesla is already developing a thermally insulated actuator system designed for exactly these kinds of tasks, slated for release in early 2026. Of course, every time a robot shows up, the same worry arises. Are humans going to lose their jobs? We asked that question too, but when we looked at our own lives and work more closely, we realized not all jobs are worth preserving, especially the dangerous, dull, and dirty ones. Tesla echoes the same reasoning shared by experts in industrial automation. Robots will take on the heavy lifting first, so humans can shift into better roles. A compelling example comes from the Accor hotel chain, which is participating in the Optimus pilot program. Instead of laying people off, they reassigned employees who once hauled linens to more fulfilling roles in guest services. Jobs that involve more human interaction, are less physically taxing, and pay better. And according to a leaked presentation covered by several reputable business outlets, within just 6 months of deploying robots, the average salary of staff in luxury hotels rose by 14%. And if you think robots are just for cleaning the house, shoveling snow, or hauling gear on a farm, think again. On a few forums, we came across questions like, "Hey Elon, can Optimus play golf?" And Elon coolly replied, We're working on torso rotation algorithms. Need an extra gyroscope in the wrist and club head speed of 30 meters per second. Yes, golf, not a joke. Tesla plans to roll out a Gen 3 sports training module that will teach Optimus how to rotate its body, grip a club, and swing. But honestly, for those not overly picky, Gen 3 is already off to a solid start. According to a Tesla engineer, Optimus Gen 3 can already tee off, retrieve balls, and even keep score, all using vision-only tracking. No radar, no complicated LiDAR, just its AI eyes. We can already picture it. A quiet weekend afternoon, you're relaxing on a wooden bench, and Optimus is gently collecting golf balls on the green, maybe taking a swing or two just for fun. It's equal parts hilarious and heartwarming. And if you're still uncertain about the future of robotics, just consider what Elon Musk said at a recent event. By 2040, there will be more humanoid robots than actual humans. Sure, that sounds a little chilling at first. But viewed from a different angle, one where these machines aren't replacing us but freeing us from the things that drain us, it starts to feel like a future worth looking forward to. For those living among fields and winds through rainstorms and long winters, or simply those wishing for an extra pair of reliable hands, Optimus represents reassurance, a quiet kind of promise. Not a far-off fantasy, but a companion that will walk beside us through every harvest, every snow-covered porch, every misty morning in the garden. So, why does the Tesla Bot Gen 3 deserve more recognition than other humanoid robots? Like Atlas? We've had those jaw-dropping moments too. Watching Boston Dynamics, Atlas, backflip, somersault, and shapeshift like something straight out of a Hollywood blockbuster. Every ninja-like spin sends the internet into a frenzy. It's stunning, no doubt. But after the applause fades, we always find ourselves asking a simple question. Can it fold the laundry? Because while acrobatics are flashy, usefulness is quiet. And that's where Tesla's Optimus makes its case, not as a stunt performer, but as a helping hand in the real world. That's the truth. Atlas, the newest electric version, is undeniably a technical marvel. But as The Verge pointed out, the recent video was actually the first time it ran fully autonomously. All those jaw-dropping parkour stunts, they were meticulously pre-programmed. Not exactly what you'd call freeform AI. And the price tag? Well over $200,000. And it's still just a prototype, not a commercially available product. Now let's talk about Tesla Optimus. It doesn't do backflips. It won't leap off platforms. But it folds laundry, unloads the dishwasher, waters plants, carries groceries, and makes the bed, all while working 8 hours a day, consistently, without complaints. And if you do the math, with a projected price of $20,000 to $30,000, that's less than $2 an hour in depreciation. No lunch breaks, no paycheck, no insurance benefits. Sometimes the most revolutionary thing isn't what turns heads, but what quietly gets things done. Tesla is betting on a very different strategy. Less show, more substance, like a Toyota Camry parked among a lineup of supercars. It's durable, practical, and most importantly, meant to be owned by real people. And for folks like us, people who need a helping hand to weed the garden, walk the dog, or care for aging parents, a robot that can stay balanced while rinsing a glass is what we call worth the money. So if the question is, can Optimus keep up with Atlas? Our answer is, it doesn't need to. Optimus is on its own path. And that path, we believe, leads not to center stage, but to every home. How did the Doge exit really change the game for Tesla Bot Gen 3? Here's something most people missed, but it matters a lot. When Elon Musk freed up his personal schedule, Tesla also freed up its investment budget. Sounds strange, but it makes perfect sense. Tesla's CFO, Vaibhav Taneja, recently revealed that in 2025 alone, the company will pour $2.3 billion into just two core areas, Optimus and the Dojo machine learning cluster. And if that number sounds huge, that's because it is. It's 3 times what Tesla spent last year. This isn't just money. It's a real commitment. Musk stepping back from Doge and stepping up at Tesla didn't just change headlines. It redefined priorities. Optimus Gen 3 isn't just a side project anymore. It's front and center, with the budget to match. Why does it take that much money? Because every single Optimus Gen 3 unit is connected to Tesla's always-on training pipeline. So if Optimus is truly the next growth engine for Tesla, and if Elon Musk says Optimus could cost as low as $10,000, why are we hearing rumors of a $1,200 per month lease? Is this affordability or just another luxury tech trap? Please share your opinion in the comments section below this video. Since leading Tesla, Elon Musk has never followed the same path as his competitors. He always wants the company's products to be different and somewhat weird that customers cannot find in Ford, Rivian, Toyota, or any other company. And not only electric cars, now it happens on the company's humanoid robot product, Optimus Robot. The difference here is the way Tesla develops Optimus, unlike competitors who only focus and spend a lot of money so that the robot can run, jump, or have an intelligent brain. Elon Musk said that Tesla does not follow that direction. More than half of the company's engineering team's efforts are focused on one thing only: the hands. With the vision of the richest man in the world, Musk believes that almost all human intelligence is done through the hands. Musk emphasized that throughout millions of years of evolution, no part of the human body is as important as the hands. Even in the early days of human cognition, our ancestors were able to build great structures and perform complex tasks without the need for advanced thinking. That is why Elon Musk and Tesla chose hands as the technical focus of Optimus the robot. Musk believes that with these hands, Tesla Bot will create a large gap with its competitors and allow Tesla Bot to become the most sophisticated humanoid robot in the world. 100, 500, or thousands of tasks will be solved by this robot. And today's episode is all you need to know about Optimus's hands.
New Optimus 22 degree of freedom hand and forearm is now in production. And it's learning to walk and catch balls. It's pretty cool. I mean, look, that's where we came from. It's wild. So in a very short period of time, Optimus has gone from being an idea to the most sophisticated humanoid robot on Earth. If you want to have a humanoid robot that can do things that a human can do, it's a very high bar. So our new arm has 22 degrees of freedom instead of 11.
Recreating the movement of the human hand in a robot, it turns out, is never a simple task. And the best engineers in the 21st century know that they are racing against time to catch up with the 2 million years of evolution that have made the human hand the most complex, biomechanical structure ever to exist on Earth. If you were to name a body part with the most complex motion, it would be the hand. The human hand is capable of a myriad of movements from grasping, pulling, pushing, flicking, pressing, and chopping. List a similar list of movements for any body part, and the hand would surely never be defeated. That is why Aristotle once asserted that the hand is the tool of tools. Our hands have 27 degrees of freedom, and we can do any job within our capacity with our hands. With 5 flexible fingers, hundreds of sensory nerves, and an extremely sophisticated mechanical structure, the human hand is the perfect tool for creativity, labor, and intellectual expression. Therefore, creating a machine that can simulate the flexibility and sophistication of the human hand has long been an ambitious dream in the field of robotics. It is a technological pinnacle that thousands of engineers from all over the world have been trying to reach for decades. However, when Elon Musk announced that the next generation of Optimus's hand has 22 degrees of freedom, Tesla Optimus once again shook the technology industry and created many discussions. Not because of its geometric figure or advanced AI brain, but because of something that few people expected: a pair of hands that are very different from human hands. A hand that has 11 degrees of freedom now has 22 degrees of freedom, which allows it to be only 5 degrees of freedom, less than a human hand. To put it simply, the 11 degrees of freedom hand has allowed Optimus to fold clothes, water plants, hold eggs without breaking them, install electronic components, carry battery trays, and even serve drinks. That's just the beginning, because it's clear that both Optimus's brain and hands are still quite primitive. But this makes us even more curious about how sophisticated a 22 degrees of freedom hand will be. When watching Optimus in action, we have to admit that we are not attracted by the unnatural gait. Like people often joke that Optimus walks like Biden, although that gait greatly affects the ability to maintain balance or smoothness in body movements. However, when watching Optimus manipulate objects with his hands, we believe that we all feel it is at least impressive. Late last year, Tesla released a demo of its new 22 degree of freedom hands, showing Optimus catching a tennis ball with great precision. But few people know that it took a huge effort for Optimus to do that, because 50% of the mechanical complexity of the entire robot lies in this new generation of hands.
Yeah. The hand might be close to half of all the engineering in Optimus. From an electromechanical standpoint, the hand is probably roughly half of the engineering. We tried putting the actuators in the hand itself, but then you sort of end up having these like
giant hands.
Yeah, giant hands that look weird.
In humans, each finger has 3 joints and a complex network of interconnected muscles. Replicating all of these movements in a robotic hand while maintaining the size of a real human hand is a remarkable feat of engineering. Tesla has announced that Optimus features 22 degrees of freedom just in the hand alone, an unprecedented number in any commercial humanoid robot to date, where most have only 5 to 6. Each finger can move independently, rotate, bend, twist, and even perform delicate touches just like a real human hand. This means Optimus isn't limited to simply gripping or releasing objects like most robots today. It can also carry out intricate tasks like typing on a keyboard, washing dishes, and much more. One of the key reasons Optimus's hand stands out is because Tesla chose a motion system directly inspired by the human body, something the robotics field has long considered too complex and difficult to mass produce. Instead of cramming motors directly into the hand, a common approach that often results in bulky, heavy designs, Tesla moved all major actuators down into the forearm. Then a system of elastic cables mimicking human tendons is used to pull, release, flex, and extend the fingers. This system works exactly like the human hand. Muscles in the forearm contract and transfer force through tendons to control finger movement. The result, a robotic hand that is lighter, more agile, more energy efficient, and capable of extremely precise responses. Each cable includes integrated force feedback sensors, allowing Optimus's AI to feel the grip strength and adjust accordingly. Thanks to this, the robot can hold an egg without breaking it, tighten a screw with the right amount of torque, lift a coffee cup without spilling, and even sense the varying softness or firmness of different objects. This level of dexterity used to be confined to high-end robotics labs, but now it's housed within the hand of a commercial product. To achieve such ultra-compact and powerful actuation, Optimus needs to use high-performance servo motors and, crucially, permanent magnets made from rare earth elements. Unlike the large electric motors used in cars, a robotic hand requires extremely small motors that are still strong and highly precise. This presents a significant challenge for Tesla, as only ultra-powerful permanent magnets can meet these demanding specifications. However, over 80% of the global supply of rare earth magnets currently comes from China. Amid ongoing tariff tensions between the two countries, China has started tightening its export controls to safeguard its national technological interests. This has created serious difficulties for Tesla in sourcing these critical components.
Optimus was affected by the magnet issue from China because the Optimus actuators in the arm do use permanent magnets. Now, Tesla as a whole does not need to use permanent magnets, but when something is volume constrained, like an arm of the robot, then you want to try to make the motors as small as possible, and then so we did design in permanent magnets for those motors, and those were affected by the supply chain, by basically China requiring an export license to send out any rare earth magnets.
Raw materials aren't the only challenge. To maintain near-perfect precision in the hand of Optimus while performing tasks, the motors, sensors, and cable systems need to be calibrated in the most optimal way. According to Milan Kovac, the lead engineer of the Tesla Optimus project, the team is currently focused on several key improvements, especially in integrating a new tactile sensing system. One major highlight is that this new layer of tactile sensors will cover a significantly larger surface area compared to the previous version, giving the robotic hand an improved ability to feel, including texture, pressure, and even temperature of the objects it touches. As seen in a video of Optimus catching a tennis ball, once the robot catches the ball, it doesn't immediately let go. This indicates that Optimus is ensuring it has a firm grip, even visually confirming whether what it caught is indeed the ball. All of this is made possible by tactile sensors that allow it to truly sense the object in its grasp, something that most of Tesla's competitors haven't achieved yet. This upgrade isn't just about adding sensors, it requires complex tuning of the control system. The engineering team is implementing a control mechanism based on artificial tendons, a system that mimics the tendons in a human hand to enable smoother and more precise movements. This allows the robot hand not only to open and close, but also to perform delicate tasks like handling fragile items, typing on a keyboard, or even distinguishing the hardness of various materials. However, these advancements also come with new challenges. Integrating such a complex control system into the forearm has unintentionally increased the weight in that area. This affects the overall balance and the robot arm's ability to operate continuously. To address this, the development team is now working on reducing the weight of other components without sacrificing power or precision during operation. Another key aspect of the improvement process lies in designing the protective covering for the fingers and palm. This layer needs to be soft and flexible enough to ensure both dexterity and compliance when interacting with humans and the environment. At the same time, it must be carefully engineered so it doesn't interfere with the hand's tactile sensing capabilities. This presents a difficult technical challenge. If the protective layer is too thick, the sensors become blind. If it's too thin, the hand becomes vulnerable to wear and damage from frequent use. All of these upgrades are aimed at one ultimate goal: to create a robotic hand that is not only strong and precise, but also capable of feeling the world like a human hand. A major leap forward in making Optimus a truly useful assistant in everyday life. Tesla began testing Optimus on the production lines at the Fremont factory in early 2024, where the robot has been operating as a worker. A robot that just walks and talks doesn't offer much real value, but with a hand that's both flexible and powerful, it can perform real-world tasks, from the factory floor to your home. The Optimus robot can now pick up tiny components, tighten screws, apply adhesives, assemble devices, transport fragile items, and even inspect products for defects using its tactile sensors. Once introduced into homes, Optimus, equipped with its highly dexterous hands, could do laundry, fold clothes, cook, wash dishes, mop the floor, clean up, open doors, carry groceries, or play with pets. Beyond practical applications, Optimus's hands also open the door to social interaction. A robot that can clap, shake hands, gently touch a shoulder, or comfort an elderly person with a soft stroke on the back of the hand creates a new level of emotional connection. This is especially important if Optimus is used in elder care centers, hospitals, or special education environments, places where gentle physical contact can make patients feel cared for and understood. With its integrated tactile sensing system, Optimus can determine the appropriate amount of pressure to use when touching a person. Not too strong, not too weak, ensuring a safe and pleasant experience. Although Elon Musk has repeatedly mentioned a $20,000 price point, we remain quite skeptical of that figure, especially given that Optimus is currently facing two major production challenges: high-performance permanent magnet motors and supply chain constraints.
Almost everything in Optimus is new. There's not like an existing supply chain for the motors, gearboxes, electronics, actuators, really anything almost anything in the Optimus, apart from the AI for Tesla, the Tesla AI computer, which is the same as the one in the car.
It's clear that not everything can be reused from Tesla's EVs. Everything in Optimus must be balanced in both size and power. In an EV, adding a few dozen pounds isn't a big issue, but for a humanoid robot like Optimus, weight directly affects performance and mobility. That's why building Optimus, especially in its early stages, was never going to be easy, even with Tesla's world-class engineers and massive factories. Progress will likely be slow, and production costs won't be low enough to realistically hit a $20,000 price tag anytime soon. Elon Musk himself has acknowledged that producing 1 million Optimus units per year might not happen until 2029 or 2030. That's why we believe it will take about 5 more years before Optimus can be priced at $20,000. If Tesla begins selling a limited number of units next year, we estimate the price to be around $40,000, roughly the cost of Model 3. At that price point, many middle-class American households might be willing to invest if the robot can reliably work 8 hours a day. Tesla has emphasized that Optimus is equipped with a multi-layered behavioral AI system. It records every hand movement, analyzes applied force, and will automatically shut down if it detects any dangerous behavior. Tesla also includes over-the-air software updates and role-based control restrictions, ensuring Optimus cannot be turned into a weapon by its user. A key question remains: why is Tesla, an EV automaker, investing in humanoid robots? The answer lies in the transition from virtual AI to actionable AI. No matter how smart artificial intelligence becomes, it's still just software if it can't interact with the physical world. The hand is the bridge between software and the material world. And with a hand like Optimus's, Tesla is paving the way for an era where AI can truly do things for humans. While Optimus carries the mission of transforming human labor and daily life, Elon Musk has been upfront in admitting that the Tesla Bot will have bugs when it first launches. That's completely understandable, considering that humanoid robotics is an incredibly complex field, where every movement, response, and decision must be nearly flawless, yet must be learned from scratch. One of the first noticeable weaknesses is Optimus's object recognition accuracy, which still leaves room for improvement. Due to a lack of sufficiently diverse visual data, Optimus can confuse similarly shaped objects, leading to errors during task execution. Another major concern is response latency. The robot may react slowly or misinterpret commands, especially in noisy environments or when signal interference is present. In terms of mobility, while Optimus is equipped with balance control, it still risks falling when navigating thick carpets, high steps, or unexpected collisions with pets or obstacles. Moreover, the robot's voice recognition is not yet fully adaptable, particularly when users speak unclearly or use non-standard vocabulary. Its reliance on internet connectivity further adds to the risk of interruptions. If the network is unstable, data may fail to sync in time, causing the robot to freeze or behave incorrectly. Beyond technical limitations, Optimus also faces manufacturing challenges. Tesla can't simply reuse the existing EV component supply chain. Most parts of the robot must be newly designed and built from scratch. Elon Musk has also expressed concern over China's dominance in the permanent magnet supply chain, which could seriously impact Tesla's production capabilities. Altogether, while Optimus represents a major leap forward, its path to success is still filled with numerous challenges that must be overcome. In a world where humans are seeking freedom from repetitive, tedious, and potentially dangerous tasks, the hand of Tesla Optimus could become the first true symbol of technological liberation. This is no longer just a story about walking robots or smart AI, but about a pair of hands that can feel, act, and change the world. What do you think about Tesla Optimus? How do you feel about its hands?